this is going to be part 3 of your chapter 3 practice AB problems. This video is going to go into your practice AB actual problems by doing the sample problems on them. So with that in mind, let's begin. Here's a sample problem that's going to be like the actual sample problems that you'll work on. So looking at this, it says a car travels for 105 meters in an eastward direction. After 10 minutes of travel, the car makes a right-hand turn and begins to travel south for a distance of 55 meters. Show the resultant magnitude and direction by using the guess method. So the first thing we want to do is change this now. We are going to use I guess, whereas the I stands for now the image that you will want to draw for these different pictures. So the first thing that we see is that it's traveling eastward, and then it makes a right-hand turn. Now it's traveling south. So here's what our picture is. So we should have a positive y and a negative x. We're going to be solving for the resultant on this. So going into the problem, you know that you have a displacement in the x direction of 105 meters. You have one in the y direction of a negative 55 meters because you're traveling south. And you know that your time here is 10 minutes. Okay, so with that in mind then, what we want to try to figure out is our resultant in meters, and we want to figure out theta in degrees, and we're also going to be going blah of blah. We just don't know yet. So the original given here is we want to use our Pythagorean theorem of x squared plus y squared equals r squared, whereas the square root of x squared plus y squared equals r. So get your calculators ready. That would be 105 squared plus negative 55 squared equals square root second answer equals. So check that out for a second, guys. Don't just sit here and let me do it for you. 105 squared plus 55 squared, square root it equals. Your calculator answer should be 118.53. From that, you know, looking at your givens, because time is irrelevant, you want to sig figs to 120 meters is your R value. Theta is going to be the inverse tan of opposite over adjacent. So looking at your picture here, opposite is y, adjacent is x. So therefore, this is a bow tie triangle that we are dealing with. So y over x, that is the inverse tan of negative 55 over 105. That is going to equal 27.64. Once again, make sure you're in degrees and not radians. So therefore, theta equals 28 degrees. And then in what direction? You traveled how second and then first. So you went south of your eastern line. So 28 degrees south of east should be your final answer there. Notice how you don't have to put negative 28, because like negative 28 south is like two negatives that'll cancel each other out. So 28 degrees south of east would be the correct answer here. Okay, so once again, to subtract these vectors here, obviously all you're doing is just looking at its opposite. So if you have a positive 30, a negative 30 would read this way. So you could say 30 meters per second towards the west, right? Wouldn't that make sense? Okay, so that's pretty much all I want to say on that. So you're going to have some problems. Like think back to your chapter 3 pre-test, like the orange-ish color thing that we have you do. Like the second question I want to say, it says like if C equals A plus B, then what would this triangle look like? Whereas A looks like this and B looks like that. So then very clearly you guys would write, that's my C. But what if it would say C equals A minus B? So A would still look like this, but now B would be the opposite of it. So therefore you would still want to draw this, but now you draw this. So now your C would be heading down this way. Make sense? So the opposite. Think of negative as meaning opposite, not negative number or negative quantity. It's this magnitude in the opposite direction. Okay, vector operation. So I'm going to give you the resultant now, and then based off of giving you the resultant line, you need to figure out your x component, and you need to figure out your y component. Knowing that, once again, theta is placed in between your first vector drawn and your resultant line. So looking at this, to figure out x stuff, you'd be going adjacent. So you're going to use cosine theta here, whereas your y is going to be sine theta because because you're moving opposite and your hypotenuse is known. So opposite over hypotenuse, sine theta, adjacent over hypotenuse, cosine theta. Once again, because the hypotenuse, the resultant, is known going into the problem. So you're going to use your Pythagorean theorem, x squared plus y squared equals r squared, to figure out the resultant. Pythagorean for resultant. And then you're going to use tangent to figure out the direction. So it depends. If you have a bow tie triangle, then you're going to use, if you have a bow tie triangle, then you're going to use theta equals the inverse tan of opposite over adjacent, which would be y over x, or if you have an hourglass, therefore, theta would equal the inverse tan of x over y. Think back to when we drew those bow ties and hourglasses, okay? Where is your opposite, where is your adjacent, where is your hypotenuse in relationship to theta? Okay, so let's try this first problem here together. For this first problem, it says that an archaeologist is climbing, so that's a delta y, of 136 meters. The pyramid itself is 2.30 times 10 to the second meters wide, and it wants you to figure out her resultant in meters and her theta in degrees. Well, there's one problem here. A pyramid looks like this. You only want half the pyramid. So this is a given in your problem. You need to write that number down, but then just simply write whatever half of that is, which happens to be 115 meters, right there by the givens. Okay, so let's solve for magnitude first. Magnitude would simply be you using your Pythagorean theorem. So you would have the square root of x squared plus y squared equals r. Calculators, please. So that would be 115 squared plus 136 squared equals square root second answer. So 115 squared plus 136 squared equals square root second answer equals, you should see 178.10 on your calculators. Looking back at your givens, the givens, not the numbers that you ultimately use, but the numbers that were given to you, you see that you want 3 sig figs. So therefore your final answer should be 178 meters equals your resultant magnitude. Okay, so your direction is going to be the inverse tan of opposite over adjacent. Check this triangle out, guys. The triangle that you ultimately drew, the blue lines here. This is a triangle that we ultimately drew. Agreed? Here's your delta x value, here's your delta y value, here's your r, and then I already placed theta. So you want to go opposite over adjacent. So this is going to be inverse tan of y over x. So that would be the inverse tan of 136 divided by 115. So the inverse tan of 136 divided by 115. Enter. You should get 49.78. Once again, sticking with your 3 sig figs, therefore theta equals 49.8 degrees. That's it. The problem didn't say like north of east, south of west, etc., etc., so don't put it in there. Okay, so now you're going to solve for the sides. Another word for the sides is the components. So you're going to look at your x and your y components. Okay, you're going to use sine theta, opposite over hypotenuse, for the y component, and cosine theta, adjacent over hypotenuse, for your x component. Now that is going to be for bow tie triangles. Let me show you why. Here is a simplified bow tie triangle, quadrant 1. Here's your x value, here's your y value. Here is your resultant side, i.e. your hypotenuse side. So opposite over hypotenuse is your y stuff. So therefore, opposite over hypotenuse is sine theta. Okay, so now we have x. We have adjacent, over hypotenuse is going to be cosine theta. So that's how we figure that out. So now let's look at an hourglass. So for an hourglass triangle, you're going to say that sine theta is now going to be your, well, it's still your opposite over hypotenuse, but now it's going to deal with your x component, and cosine theta is now going to deal with your y component. Makes sense because you're heading like this now, whereas now your y is adjacent and your x is opposite. Opposite goes with your sine, adjacent goes with your cosine. Let's look a little bit more clearer at this here. When we want to look a little bit more clearer at this, I'm just going to throw this in here, is you really want to look at these equations. Sine theta equals opposite over hypotenuse, and cosine theta equals adjacent over hypotenuse. Well, really guys, what we're saying here is that sine theta equals, now I'm going to do this for bow tie triangles. Okay, so what we're saying here on this, that your sine theta is going to be your y over your r. So let's solve for y, right? Because that's ultimately what you're going to do is solve for this. Solve for this component right here. So therefore, that equation is now going to become y equals sine theta times your resultant. Okay, let's look at this guy right here. So that would really mean cosine theta, check that triangle right up there where it says b dot t dot. Okay, so that would be your x over your r, your adjacent over your hypotenuse. So therefore, if you're solving for your x component now, then that would mean that the equation you want to use is x equals cosine theta times your resultant. Now those are for bow ties. So for hourglasses, we just think oppositely, right? So your hourglass equations, let me do this in a different color so we can have a real nice distinction here. An hourglass triangle, such as this guy, would mean that your y component is now cosine theta times resultant because your y is now adjacent to theta, whereas your x is now opposite of theta. And since your x is now opposite of theta, you're going to now be sine. Okay, so let's actually try this problem B now here. So for problem B here, it says, find the components of this velocity here. So this is given to you. This line, this resultant line is given to you, and this theta is given to you. So you will need to solve for your x and your y components. That's ultimately what you're going to be looking for, whereas resultant and theta are given to you. So knowing this, it says that you have a resultant, and I'm going to call it v sub r because it's a velocity, of 95 kilometers per hour. And you know that theta, your resultant theta, is 35 degrees to the ground. Well, to the ground is moving, downward. Okay, so anyways, you want to solve for your v sub x in kilometers per hour, and you want to solve for v sub y in kilometers per hour. So you need to assess over here. Do I have a bow tie, or do I have an hourglass? So I know if I want to use the sine with x, or if I want to use the cosine with x, and then the same thing for y. Okay, so looking at this, you know that it is just like a first quadrant bow tie. So this is a bow tie triangle. So to solve for your x component, check this previous slide. Solve for your x component of a bow tie triangle, you want to use cosine theta times resultant. Whereas cosine of 35 times 95. So put that in your calculators, making sure you're in degrees again. Cosine of 35 times 95. That is going to give you roughly 78, in which you only want 2 sig figs, so 78 kilometers per hour is what v sub x equals. Okay, v sub y is now going to be sine theta times your resultant, in which sine of 35 times 95, throw that in your calculator, sine 35 times 95, is going to give you roughly 54. So therefore, v sub y equals 54 kilometers per hour. Okay, for practice A, you should have 8 final answers. For practice B, you should have 6 final answers due on Monday. Great job, guys. Great job. 3 videos done. Chapter 3, practice A, B, 3 videos. Good job.